If you want to be successful in drawing the graphs of the transformations of the parent function y equals log base 2 of x, there's two things you really want to make sure you pay attention to. Number one, you want to make sure you understand that the key point of any log function is always 1, 0. Because when x is 1, y is 0, because the log base anything of 1, any positive number bigger than 1, the log base any positive number bigger than 1 of 1 is always 0. Because any number greater than 1, in fact any number greater than 0 for that matter, raised to the 0 power is equal to 1. So the log has a value of 0 when x is equal to 1. So that's the first thing. Make sure you know where the key point is, the shape of the graph, as well as the vertical asymptote. So the vertical asymptote on the parent function is the equation x equals 0. So when we look at this transformation here, log base 2 of negative x plus 2, we want to go through our list of transformations. If we're going to reflect about the x-axis, then there's going to be a minus sign right there. So notice there's no minus sign there, so we're not going to reflect about the x-axis. The next thing we look for is, are we going to reflect about the y-axis? If there's a minus sign in front of the x on the inside of the parentheses, then yes, we will reflect about the y-axis. So the original parent function, I'll draw this in pencil, goes through 1, 0, and it comes around and it curves out like that, hugging the x-axis over here to the right. As x gets bigger, the y values don't get bigger that fast, so the graph has a shape like that. The vertical asymptote again is x equals 0. If we're going to reflect that graph about the y-axis, then that point, which is at 1, 0, gets reflected to negative 1, 0. So, and then the graph like this, like folding that graph over the y-axis. And so the graph would look like that. So you can see it, a little dashed line there. So we're not done yet. The next thing we want to look for is, are we shifting in the x direction? If there's any number inside the parentheses, if there's an h other than 0, being subtracted from x, then we would shift in the x direction. But as you can see, there's no number being subtracted from x, so therefore we won't shift it in the x direction. The last thing we're going to look for is, are we going to shift it in the y direction? And that would be if the k value is something other than 0, which it is. We can see here that k is equal to 2. So if k is equal to 2, that means we're going to take this graph right here that we already reflected about the y-axis, and we're going to move it up 2 units. So moving it up 2 units, the key point moves up 2 units. Now the key point has the coordinates. Let me write key point here. The key point has coordinates negative 1, comma 1, 2. So negative 1, 2 are the coordinates of the key point. And then we're just going to go ahead and draw the graph through the key point and off to the left like that. It's supposed to be approaching the asymptote. It gets hard to do that. But the asymptote didn't change because we didn't move the function log base 2 of x to the right or to the left. That's the only time you would ever move a vertical asymptote, is if you're shifting the graph to the right or left. Shifting it up or down doesn't move the asymptote because it's vertical. So you don't move a vertical asymptote up or down. So that takes care of the graph. And let's go ahead and take a look at the defining characteristics. When we look at that graph, we know that the domain is, think about this, the argument, which is negative x. So for the domain, the argument must be non-negative. Sorry, the argument must be positive. So argument, I'll go into more detail on this first video. The argument must be positive, and the argument is negative x has to be greater than 0. So if you're doing this algebraically, you would divide both sides by negative 1, and therefore you would get x. And when you divide by a negative, you flip the sign. So x then would have to be less than 0. And we can even just look at the graph. We can see that this graph covers all x values such that x is less than 0. Remember, the range of all log functions is always all real numbers. This function happens to be decreasing as x increases so as x increases from negative infinity to 0, we see the y values are getting smaller. So We don't have any intervals on which the function is increasing. We do, though, have the interval from negative infinity to 0 on which the function is decreasing because, again, the y values are getting smaller on that interval. There are no horizontal asymptotes with log functions. There is, however, like we said, a vertical asymptote. Make sure you include the equation x equals 0. And then for the x-intercept, what we're going to do here is over here to the left, x-intercept, now that you know how to solve log equations, we're going to go ahead and let y equals 0. And when we let y equal 0, we get 0 equals log base 2 of negative x plus 2. So that means if we subtract 2 from both sides, we get log base 2 of negative x is equal to negative 2. And again, now that we've had that lesson on solving log equations, we see that our variable is locked up in the log. And so we're going to go ahead and unlock it by converting this equation to exponential form. And to take the 2, the base, raise it to the opposite side here. Base raised to the exponent is equal to negative x. And so that means we have negative x equals 2 to the negative 2. That's 1 over 4, 1 over 2 squared. And if we multiply both sides by negative 1 or divide both sides by negative 1, we get x is equal to negative 1/4. So that's our x-intercept, negative 1/4, comma, 0. For this particular graph, we don't have any y-intercept. There's never a max nor a min on a log graph. 1 to 1, yes, passes the horizontal line test. We won't worry about the slope for right now. Slope is decreasing, but we could put just NA for that, and there's no vertex and no axis of symmetry.